So yeah, so let's move on to the second panel. That's the final panel. So I would like to ask panelists to come and join me for this. I'm not sure how many speakers are still on the call. Motaz, Fred, Ali, yeah, Ali is here with us. Fred, can you hear me?
Yep.
Yeah, Fred is also online. Do we have Motaz on the call? Let me see. I don't think so. Yeah. So, Dennis and Charlie Van's replacement and Motaz are gone. I think we have just Fred and Ali. Brilliant. So yeah, we can have the second panel. I can also join you for answering any questions. So and let's have a look at the Padlet. Okay, so the first question on the Padlet is, how do you see the role of 4D printing in the circular economy?
Right, would like to go ahead?
Yes, please. Ali, yeah, you can.
Okay,
you can
we're waiting for me. Oh, is it? Let me check. Okay, yeah. Yeah, we are working currently on the biodegradable materials. And let's say for some application in ocean, and we are thinking to deploy some structures into the ocean in order to be able to grow some plants on it and some sort of the lattice, and is in the phase of 3D printing currently, but we are thinking about some sort of the 4D printing in terms of the structure. I'm not sure whether even degradation or biodegradation could be counted as a 4D effect, but I think so, because it still is with time. We could have some materials that could be defined with the lifespan. And also that's a good time. I like to always add about that 5D printing, 6D printing, and so on. I like to keep it on the 4, because I think that we have 3 dimension already, and then time is coming to effect. So that's why this is my personal belief that I always like to say, and that's why when the time comes to the effects, that time could be applied when I say the degradation, that's the materials that you print, it has a properties, and then when it goes to their use over the time, the degradation could be part of that 4D as well. We can predict that, we can design that life expectancy and these sort of the things as something like the 4D printing in the circular economy. And the next things about that of course we have the waste reduction as part of the 4D printing. And the simple example that comes to my mind is the support materials, that we may remove that support materials with having the self-assembly of the products as part of the 3D print. And these are the things coming to my mind regarding the circular economy and waste minimization is a 4D print.
Exactly. So the extra dimension can reduce the demand for resources like supporting materials. And at the same time, we can also use this kind of sustainable materials as a small materials we use for 4D printing. And even we can also consider degradation as a part of the 4D printing. So once they do their job, they can also start degrading or we can recycle them. Fred, any thoughts on it, or would like me to go to the next question?
I have no major opinion on this.
Okay. Brilliant, thank you. And so next question is, what are the practical and direct application of the shape memory alloys, alloy-based 4D printing in the different industries? So Motaz worked actually heavily on the shape memory alloy painting, and do you have any comments on this?
Not much from me.
I think that SME can be used in a space, automotive, even biomedical sector. That most of the stands, current stands, are made of, let's say, metal. So I think SME could be also used for stands. As far as I know, SME exhibits much more mechanical properties than traditional polymer-based shape smart materials. So we can imagine it building innovative shape memory alloys in the future, whether nitinol or even a copper-based alloy, whatever. The future is open for this kind of material.
Yeah, actually, before 4D printing, shape memory alloys have a lot of applications in aerospace and medical. So yeah, but with the 4D printing, we can kind of print them in a faster way, or even we can print them in a space. So imagine having a printer up in the space can help us create the things we want, especially when it comes to shape memory devices. Yeah.
Maybe one of the limitations would be the training step.
The training.
Like SMP, you need to introduce a training step. So if you plan to build a complex structure, it would be hard to train the part during the printing or even once printed.
Yeah, exactly. At the moment, there are some groups who are working on the 3D or 4D printing of the shape memory alloys, but the challenge you mentioned is huge. You can print some materials, but they may not have phase transformation. They may not have shape memory feature. So although the material is the same of the the original material, but AM process can affect them, can affect the shape memory behavior, and the training post-processing is a must actually for these materials. Yeah, thank you. And
now I'd like to add, based on your discussion, that the term of that heterogeneous 4D printing, I like that one. Not necessarily we can, because currently we couldn't get to that point of printing shape memory alloy properly, but we can use them as a wire or cable to add on and integrate to the 3D printing parts. And that heterogeneous, I remember that from the Temoli's PhD student thesis. I remember that, and I like that. And then now we are using it in the robotic or soft robotic. That's a current application.
Yeah, exactly. Especially, when it comes to the actuation, to the force dimension, sometimes you need the force to do the job, and polymers may not create forces large enough to do the job.
Correct.
And the shape memory alloys or shape memory materials with high stiffness actually are needed, and perhaps multimaterial printing with these materials along with polymers could be a great option. I know Fred is working on that, so hopefully in the future we will see multi-material printing where you have the polymers and metals printed at the same time. Is IP under IP protection. Okay, so regarding the third question, how can 4D printing address the limitations and defects that we see in the 3D printing? Do you think can we use 4D printing to get rid of or reduce the effect of the defects? Something like self-healing?
That was a good point. I didn't look at it from this aspect.
Yeah, for example, I'm working on a project. It's about the soft gripper 4D printing, and because after some cycles you will see some cracks in the soft robot. So I was wondering if we can have some self-healing materials that can kind of repair that damage, or even fill some defects generated by AM.
Yes, like that IoT things that we discussed, maybe that sensor could come into effects as part of the 3D printing structure, that we have that 4D printing or smart materials used to detect that defect that you mentioned. That could be one possibility as well. Just came to. But self-healing should be interesting as well.
or even liquid. You can print some liquid along, or some kind of glue along during the 4D printing, and they also even can fill the gaps, defects. Yeah.
Interesting topics, Maddie.
Yeah.
Giving me new projects.
Yeah. Yeah, that's one of the aims of this event. We would like to exchange our ideas, learn from each other to 4D print the future.
Yeah, that might be that liquid things, like the adhesive things or bonding that we can control over time. That could be interesting too.
Yeah. And the first question is, how is 4D printing being used to advance soft wearable devices and address challenges in the field? 4D printing for wearables?
Yeah, this is what we are doing with our current PhD student that we recently presented in that our last 4D Printing Society conference, that we're working on the tremor that for vibration suppression, and is good. We have got some promising results in terms of the vibration reduction with changing the stiffness, and now we are working on another stage of the project that hopefully in next 6-7 months we will get some result out of that, and the final product we'll see how we are going to have the wearable 4D printed design in terms of the variable stiffness, so that we can reduce the tremor in Parkinson disease people. And yeah, this is one thing we are working on. That we are not considering the sensors at this stage, but there could be sensor like the closed loop feedback things involved as well for these wearable things.
Yeah, great. Yeah, exactly. And even I think Frederick's expertise on the voxels can be used as well. For example, if you want to 4D print the wearables, and then they can do the kind of a specific activation by considering the different actuation in different places. Yeah. Another project we are working on that is a printing of the socks that can actuate and do the massaging, for the elderly, so it can increase the blood flow. Okay, so let me go to the fifth question. What are the current challenges for using 3D and 4D printing for tissue regeneration? Any thoughts on that? Tissue regeneration, although Dennis and Dimitris are not on board, but
yeah, another project we are working with some PhD student in joint universities PhD student on the vascularized with the Falguni, and from IITH we are working on the vascularized tissue engineering 4D bioprinting, and like the gelatin-based material we are going to have, and in order to add some more branches or vascularize the paths to the tissues, we are working on that, so how we can get some sort of the morphing and vascularized growths in order to have more viability for the cells viability and the functionality of the blood vessels. This is one project we are working on it currently, is the earliest stage from the 4D perspective.
Okay, Bernard, and what are the main challenges for it?
The challenge is the cell viability is one challenge, and we are because of 3D printing, especially that the DIW, direct in writing, it has some sort of the shear stress that it affects on the cell viability, and then we need to see how we could maximize the cell viability, and then during the 3D printing, and that is one thing. And another one, the structural, mechanical properties of those materials in terms of solidification or holding their mechanical properties while they are soft enough for the cell growths. This is another aspect that is challenging to find the right spot on that.
Really, thank you. Thank you so much. I think we do not have any more questions on the Padlet for panel 2, and one thing left from panel 1 was regarding the sustainability, circular economy, and the sustainability of the 4D printing. And I just wanted to share my thoughts on that I think we haven't seen any comprehensive work project on the life cycle assessment of the 4D printed products. So I think that could be a good project for the society, for the community, for the audience in this meeting, that we can from our region. 4D printing is sustainable compared to 3D printing because of the removing a lot of the demands for resources, materials, expertise. But I think life cycle assessment is something that can be done for kind of recognizing the benefits of the 4D printing, and it can help with the circular economy and also sustainability benefits. Okay, so we are actually very close to the end of the event. Thank you so much, Ali and Fred, for being on board. Especially Ali, you're you're in Australia and it's a night time. And I would like to ask Patrick and Alan to talk about some of the activities of the network before we wrap it up. And before that, I have to actually thank heavily from these two, Patrick, Alan, plus Nancy. We've been working to organize this event in the last 6 months, and Design for AM Network has been very kind to provide this opportunity for all of us to exchange the ideas, to share our achievements, to learn more to 4D print in the future. Thanks a lot. And the founder of this network is EPSRC. So a huge thanks goes to the EPSRC, Design for AM Network, Patrick, Alan,